Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder how your brain learns new rules and sticks with them, especially when things get confusing? Well, this new study dives deep into that very question using a classic psychology game. Imagine you are playing a game where the rules keep changing, but no one tells you. You have to figure out the new rule based on whether you are right or wrong. That is kind of like the Wisconsin card sorting test, a famous tool psychologists use to study how our brains handle these changes. This paper asks a really interesting question. When we get feedback that we're wrong and we need to change our strategy, what exactly is happening in our brains? And how does our attention shift as we get better at the new rule? So these researchers used a smart approach. They had people play a computer game very similar to the Wisconsin card sorting test. While they played, they used eye tracking technology to see exactly where people were looking and how their eyes moved. This is super cool because eye movements can tell us a lot about where our attention is going. They weren't just looking at if people got the answer right or wrong, but at the tiny details of their visual attention. Here is how the game worked. Participants saw a target card and had to match it to one of 4 reference cards. The rule for matching could be based on color, shape, or number. After every 10 cards, the rule would change. But they didn't tell the participants. They had to figure it out based on getting feedback like correct or incorrect. This is where the real magic of the study happened. They could pinpoint the exact moment when the rule changed and when participants got negative feedback, meaning they were wrong. They focused on 2 key moments. First, the trial right after they got negative feedback, signaling that their old rule was definitely wrong. This is the moment they have to reconfigure their thinking, their attentional set. Second, they looked at the trials after that. As people got more consistent with the new rule, they wanted to see how attention shifted from that initial confusion to a more stable understanding of the new rule. And what did they find? Well, on that very first trial, after getting negative feedback, when they knew they had to change their approach, people's eyes did something interesting. They looked around more. Their fixation count went up, meaning they took more pauses to look at things. Their total fixation duration increased, meaning they spent more time looking. They made more saccades, which are those quick jumps of the eye. And their gaze dispersion got wider. Think of it as their attention literally spreading out more. They were sampling more information, trying to figure out what was going on. It is like their brain was saying, something's up, let's look everywhere. Now, what happened in the trials after that initial adjustment period as they started to get the hang of the new rule? This is where they saw attentional set stabilization. Across trials 3 to 10 of a rule block, as participants got better, their visual sampling became more focused. They had fewer fixations, fewer saccades, and their gaze dispersion decreased. This means their eyes were more concentrated on what mattered. And guess what else? Their responses got faster. It is like their brain was efficiently locking onto the correct rule. Interestingly, the total fixation duration didn't decrease as reliably, which might suggest that even when attention is focused, people might still take a similar amount of time to process what they're looking at. The study also looked at how these eye movements related to performance. They found that when people were sampling more broadly, looking around a lot during the decision process, they tended to respond slower. And when they made more saccades, their gaze was more spread out, or they spent longer fixating, they were actually less accurate. This is a crucial insight. It suggests that while that initial broad sampling after feedback is necessary for figuring things out, prolonged or unfocused visual sampling can actually be a sign of struggling to grasp the correct rule, leading to errors. So, what is the big takeaway here? This study provides strong evidence that eye movements are like a window into our cognitive flexibility. They show us that when we get feedback that we're wrong, our attention doesn't just magically switch. There is an initial period of broader visual exploration, a kind of mental look-around phase, as we try to reconfigure our understanding of the rules. Then, as we learn, our attention becomes more focused and efficient, leading to faster and more accurate responses. This is really important because it goes beyond just looking at whether someone got the answer right. It tells us how they got there or why they made a mistake. Traditional tests might just give us an overall score, but eye tracking can reveal these subtle trial-by-trial shifts in attention. It highlights that cognitive flexibility isn't just one thing, but a whole set of processes. And eye movements can help us tease those apart. Now, like all studies, this one has limitations. The researchers used global measures of eye movement, which tell us about the overall extent and spread of looking, but they don't tell us the exact path the eyes took or the specific areas of interest that were fixated. So, while they show that attention spread out, they can't tell us precisely what information was being examined in detail during that spread. Future research could dive into more specific eyes. tracking analyses to explore these finer details. But overall, this is a really exciting step in understanding how our brains adapt. It shows us that when faced with a change, our visual system ramps up its activity, then hones in as we master the new challenge. This research could have implications for how we design learning environments, how we understand difficulties in cognitive flexibility, like in conditions such as ADHD or developmental disorders, and even how we think about our own everyday learning processes. It reminds us that the journey of learning is often as fascinating as the destination itself, and our eyes are a powerful guide along that path. What do you think about these findings? Does this resonate with your own experiences of learning new things? Let us know in the comments below. If you found this breakdown helpful, please give it a thumbs up. Subscribe to Rubin's Mind Lab for more science deep dives, and hit that notification bell so you don't miss our next episode. Thanks for watching, and we'll see you next time.